that. No, it's not working. All right, I think we're in business. Okay, so I was going to finish 1.3 today. I think I can, and I might be able to sneak in some of 1.4. Remember, we're skipping problem 5. So we're a little bit ahead. I had planned for tomorrow still to be 1.3, but if I can get ahead, I might as well do it. I don't know if something's going to, happen later, or the computer dies or whatnot. So we'll see how it goes. Okay, and again, Friday will be our next quiz. And now that you've seen one quiz, they're going to work pretty much the same way. So after a certain amount of time, I'll stop and break you up into your breakout rooms of either 3 or 4. Okay, I'll come around and join somebody and see how that goes. Okay. And Prasanna will also, be there. He can come, maybe join a room and see if you need help on that. Okay, but from here on out, everybody's responsible for all the problems in the quiz. So I won't grade you, even though you'll be in a breakout room. I won't grade you as a group. I'll just grade you individually, but you can discuss it with each other, of course. Okay, so continuing on with 1.3, please. Okay, so let me put this away. And go back to the text. Okay, I was going to start off with number 29, bottom one there. Whoops. Okay, so I'm not sure if you can read that, but how is the graph of y equals f of absolute value of x related to the graph of f? Okay, and then below that, it says sketch the graph of y equals sine absolute value of x, and sketch the graph of y equals square root absolute value of x. Okay, and even if you can't read that, I've got it over here, so I'll get that to you. Okay, and then after that, I'm going to move on to the next page. Okay, so we do functions, composition of functions, and so on. And again, just for your benefit, I'll kind of go through, try to show you. We have to do 52 and 53. So there's 52 and 53. And let's try to show, where am I on the top of page 44, it looks like. Try to show you a little bit of this, although I know it's a little bit blurry, unfortunately. And some more there, if I can find the right angle. Help. Some more there. Okay, some are a little bit better than others. And yeah, okay. Well, that takes care of that. Okay, so for 29, y equals sine absolute value of x. Okay, so I'm actually going to do B and C. B looks like this, C looks like this, and then I'm going to go back and answer A. Okay, because I think it's a little bit better that way. Okay, so I've already shown you the graph, but pretend you don't see that. Y equals sine absolute value of x. Okay, let's think about that for a moment. Okay, now, do you agree with me? If I plug in a positive quantity or 0, it's basically the same as sine of x, right? If I plug in 0 or 1 or 2 or 3 or pi over 4 or 7 pi over 6, you can ignore the bars. It's the same as a sine function. Do you agree with that? Okay, so whenever x is positive or 0, the function stays the same. Okay, so where is x positive? Which quadrants? X is positive in quadrants 1 and 4. Okay, so I remember the sine function, sine of 0, 0. It goes up to 1 at pi over 2, then comes down to 0. Then at 3 pi over 2 goes down to -1, and then at 2 pi, it's back at 0. So that's basically the shape. Okay, that's what we have. Okay, so if x is positive, it's the same as a sine function. Okay, now the next thing, what happens if I plug in a negative? Okay, because I have the bars there, okay, if I plug in a negative number, it's the same thing as I would get if I have the positive of that number. So in other words, if I plug in -2, I get the same thing as if I plug in 2, right? If I plug in -π/6, I get the same thing as positive π/6, which means this function is an even function. It's going to have symmetry with respect to the y-axis. It has y-axis symmetry. Okay. F of -x is the same as f of x. Okay. So for the rest of the graph, I don't follow the regular sine graph. Okay. I take the reflection of this graph across the y-axis. So imagine putting a mirror here, and you end up with this thing. So this is the graph that I want. Okay. Now the regular sine function would just come down and up, right? But instead, if x is 0 or positive, it's the same as the sine function. Okay. Then because I have the bars, it becomes an even function. Okay. If I put -2 or +2, I get the same thing. If I put -40π or +40π, I get the same thing. So it's going to have y-axis symmetry. So I just get the reflection across the y-axis, which means I end up with this funny looking thing. Okay. So that's part B. Okay, C is somewhat similar. Square root of absolute value of x. Now, if I just look at the regular square root function, okay, and it's good to know this ahead of time. So if x is 0 or any positive quantity, it's just a square root function. Your basic square root function, of which you're not allowed to plug in negatives, right? If I didn't have the bars there, you are not allowed to plug in -9. But because the bars are there, I am allowed to plug in -9. I get the same thing as if I plug in 9. And I am allowed to plug in -25. It's the same thing as if I plug in 25. So once again, it's an even function, meaning you have y-axis symmetry. I didn't do a very good job there, as you can see. But anyway, you just take the reflection and you get a piece over here. All right, so now going back and answering part A, okay, about the graph of absolute value of f. The graph for x greater than or equal to 0 stays the same. Okay, so they're asking you about f of absolute value of x compared to f of x. For x greater than or equal to 0 stays the same. So quadrants 1 and 4, whatever the graph happens to be, quadrants 1 and 4 stay the same. 1 and 4 stay the same because absolute value of x is the same as the x, so the graph there stays the same. But then after that, you reflect the graph across the y-axis. Okay, so don't look at the original anymore. Now take this part here and reflect across the y-axis. Same thing over here. Take this part, reflect across the y-axis, and that's what you have. So this is what you have in general, right there. Okay. Okay, so that's problem number 29. And now I'll do some problems on the next page, which involves something called composition of functions. Okay, 1.3 composition of functions. Again, ignore any dates that you see here. So I'll show you the book. You've got stuff like F circle G, F of G, G circle F, F circle F, G circle G. Okay, F of G, G of F, F of F, G of G. Okay, so we're doing something called a composition of functions. Okay, so I'll show you one of those. And go back to my notes here. Okay, composition of functions. So when you see parentheses F circle G, almost looks like fog, F of G of X, it means this. F of G of X. So you have one function and then another function. So F circle G means this, F of G of X. Okay, and then by order of operations, you normally do what's inside the parentheses first. Okay, so even though you write F of G of X, this means you do G of X first, and then you go do f in general. Okay, so for 35, here are the functions. F of x equals square root of x plus 1. G of x equals 4x minus 3. Okay, so they ask you for all these different things. Now, I went a little bit out of order here for a reason, but I'll get to it. And the question also talks about the domain. I'll come back to the domain later. I wasn't going to do all of them. Let me start off with part A, which says F circle F. That means you want F of x. I know that sounds a little bit funny, but you are putting the same thing down. Okay, so how do I do F of x? Well, by order of operations, you do the inside first. So if I kind of cover that up, sometimes I like to do that. If you don't like looking at something, don't look at it. So I put F, the left paren, and right paren. So there it is, F, left paren, right paren. And then the next step, instead of writing F of x, inside I'm going to put what it's equal to. So what is F of x equal to? It's equal to this, square root of x plus 1. So the next step, I put this, f parentheses square root of x plus 1. Okay. And now, whatever's behind this pin right over here goes right back in here. Okay. So you can start easy. If behind this pen was a 1, I'd go square root of 1 plus 1. If behind my pen was a 7, I would go square root of 7 plus 1. If behind my pen is a mess, you put square root of mess plus 1. Okay. Well, I do have a mess, square root of x plus 1. So right there, right here, we place that with square root of x plus 1. So the answer is this funny looking thing, square root of x plus 1 plus 1. Okay, so that's the answer for part A, F circle F, which means f of x. Okay, then I was going to jump and do D that says G of G, G circle G. G circle G means G of x. Okay, so by order of operations, you do the inside first. So leave this G alone, leave the left paren alone, leave the right paren alone. So there it is. Leave the outside G, the left paren, and the right paren. And then inside, I put not G of x, I put down what it's equal to. So what is G of x equal to? 4x minus 3. So I'm doing G of 4x minus 3. Okay. And now this expression, again, maybe it's easier if I cover it up. Whatever's behind my pen here goes right in here. Okay, so maybe start easy again. G paren paren. So if behind my black pen there, suppose it's at 2, you go 4 times 2 minus 3, right? If behind my pen was a pi, I would go 4 pi minus 3. If it was E, I would go 4E minus 3. If it was W, I would put 4W minus 3. If I have a mess, I would go 4 parentheses mess minus 3. I do have a mess, 4x minus 3. So here we go. 4 times mess minus 3. 4 times 4x minus 3 minus 3. So there we go. Okay, clean it up. 16x minus 12 minus 3 is minus 15. So 16x minus 15. Okay. And by the way, I will do jumps like this, and you may do likewise for me. Okay, so you look at this, say 16x minus 12 minus 3, and you say, oh yeah, negative 12 minus 3 is negative 15. Okay, so I'll let you jump from here to here. Now, if you want to go slower and put, minus 12 minus 3 and then minus 15, you may do that. But I'll let you jump from here to here. That's not that big a deal. We're taking calculus. If you were my Algebra 1 class, I wouldn't do something like that big of a jump. But for you guys, you're all experts on algebra. Otherwise, you wouldn't be taking calculus. I'll jump straight from here to here sometimes. Okay, the domain of this is certainly all real numbers. When you have something like this, are there any restrictions on x? No. Any real number, I can certainly multiply it by 16, and then I can subtract 15 after that, right? So no big deal there. I'll come back to the domain later for that one. Okay, next ones are F circle G, looks like fog, and G circle F kind of looks like golf. Okay, so the next part, F circle G. I don't think I have the lettering correct there. Oh, sorry, this one was letter C. Yeah, sorry, this is C, not an A. That's a C. Now I'm doing A. F circle G means F of G of X. Okay, so F of G of X. So by order of operations, I leave the F alone, left paren, right paren. Okay, so F, left paren, right paren. And inside the parentheses, instead of writing G of X, I put what it's equal to. So what was G of X equal to? 4x minus 3. So I'm now doing F of 4x minus 3. Okay, and now this mess, that goes right over here. So whatever is behind my blue pen goes right there. If it's a mess, that mess goes right there. I do have a mess, 4x minus 3. So 4x minus 3 in parentheses goes right there. So now it looks like this. So I have 4x minus 3 plus 1, which is radical 4x minus 2. And I'll come back for the domain of that a little bit later. And finally, B, G circle F, means G of f of x. So again, by order of operations, do the inside first. So copy the G, copy the left paren, copy the right paren. Okay. So see, I have G paren paren, G paren paren. Okay. Now, f of x. So right here, I'm going to put what f of x is equal to. F of x is equal to square root of x plus 1. So right here, I put G of parentheses square root of x plus 1. And now this thing goes into the G function. So what was G? 4x minus 3. So I'm going to go 4 times whatever is behind the parentheses minus 3. Okay. So it's 4 parentheses minus 3. So there it is. 4 radical x plus 1 minus 3. Okay, we're finished. Just a side note, notice that these two are not the same. In case you might be thinking, well, if I do f of g, is it the same as g of f? Well, you can see clearly they're not the same. They might be the same sometimes, but they're not the same in general. Okay, now I'll go back and do some domains. So we already got the domain for D, that was all real numbers. Okay, A, radical 4x minus 2. Since you have a square root, you know that the thing underneath the square root, that has to be greater than or equal to 0. So 4x minus 2, greater than or equal to 0. That's pretty easy. Comes out to be that x is greater than or equal to half. Add 2, divide by 4. So 2 divided by 4, 1/2. So the domain is bracket 1/2 infinity. Again, bracket means count to 1/2 and on to infinity. Okay. Let me go back and show you, where was it? Yeah, letter B. Yeah, this one, B. That's pretty easy, right? This thing has to be greater than or equal to 0. So x plus 1 is greater than or equal to 0, which means x is greater than or equal to 1. So negative 1 to infinity. Okay, C is the hardest one. It's this funny looking one where you got a square root inside a square root. Okay, so Let's look at that. Okay, if I only consider this square root, let's first just consider this square root. Well, that's the same as the previous one. It's bracket -1 to infinity, right? So I'm not allowed to plug in -2, -3, -4. I'm not allowed to plug in -1.00001, right? So I need x to be greater than or equal to 1. Okay, now let's look at the outside thing. The outside thing, the outside square root, that has to be greater than or equal to 0 also. Okay, so when is this expression greater than or equal to 0? Well, that's always going to be true if this is greater than or equal to 0. Now, you know the square root function, the square root of numbers that are allowed are always greater than or equal to 0. And then if I add 1, it's going to be greater than or equal to 0 also. Okay, so I don't have to worry about that. Okay, in other words, this expression is greater than or equal to -1 always. Okay, so if I think of this, square root of x plus 1 plus 1, because it's underneath the square root, that has to be greater than or equal to 0. If I subtract 1 on both sides, I have that, but that's always true. So the domain is once again bracket -1 to infinity. Okay, so that's the domain for C, and it's also the domain for B. Okay, so that's how to do that problem. Okay, the next problem I wanted to show you was 39. Okay, so you have 3 problems that were like the one I just did. 33, 35, and 37. Okay, so I did 35, and so you try 33 and 37 on your own. Again, my object is to show you at least one of each type of problem. Okay, and now 39 and 41, they want f of g of h. F circle g circle h. So you have 3 functions. Oh boy. Okay, so we had to do 39 and 41, so I'll do one of them, and you do the other. So I did 39 for you, it looks like. F circle G circle H. And here are the 3 functions. F of x equals 3x minus 2. G of x is sine x. H of x is x squared. Whoops. Okay, so f of g of x, f of g of h means this. I know it looks kind of dizzying, okay? But if I only look at this, maybe let's just look at that. G circle H means that, G of H of X, right? And sometimes if you don't like looking at the whole thing, don't look at it, just look at a part of it. So do you agree right now that is G of H of X? And now I just put F on top of that. So F of G of H of X. So that's what I have right now. Okay, so by order of operations, I do the innermost first. Okay, so leave this F alone, leave this G alone. Okay, F, G, leave it alone. And I change H of X. So can you guess what I'm going to put in place of H of X? I'm going to put X squared. So now I have this, F of G of X squared. Okay, I know there's a lot of parentheses, but I'm going to copy F paren G paren. Okay, and instead of writing H of X, put what it's equal to, which is X squared. Okay, now I do G of X squared. So pretend all you see is G of X squared. Leave the F alone. So F paren, sorry, it's a little bit funny. F paren stays the same. So now for the function G, here it is, I substitute X squared. So if I put X squared here, it'll say sine of X squared. Okay, so it's a replacement. Pretend you erase that X, put X squared. And now this funny thing, cover that up, that thing goes in for F. So whatever's behind my blue pen here goes right there. It's 3 times the mess minus 2. 3, that's how f works, right? F of stuff minus 2. So 3 times the stuff minus 2. 3 sine x squared minus 2. So that's the answer. 3 sine of x squared minus 2. So this is a composition of functions. In this case, you have 3 functions. All right. Okay, then all that I had left was 52 and 53 for 1.3. They have to do with graphs and tables in the book. So I have to show you that. Unfortunately, we know from experience that when I show you the book, it's a little bit fuzzy, unfortunately. But again, if you have the book, just go by the book. So I'll have to read part of it. Okay, so 52, please. All right. I'll read part of it in case you want to get it. So the table for 52, x goes 1, 2, 3, 4, 5, 6. And they say f of x and g of x. So reading across for f of x, it's 3, 1, 4, 2, 2, 5, looks like. Again, 3, 1, 4, 2, 2, 5. And then g of x goes 6, 3, 2, 1, 2, 3. Again, if you have the book, just look in the book. Again, 6, 3, 2, 1, 2, 3. Okay, use the table to evaluate each expression. Okay, so there really isn't any work here. You just look at the table. So it's a composition of functions. By order of operations, do you do the inside first or the outside first? You always do the inside. Okay, so it looks like for each of these, you do the inside, you get an answer, and then you apply the outside. Okay, so A says f of g of 1. So let's look at g of 1. So for the g table, g of 1 is 6. So now I have 6, which means I'm now doing f of 6. Okay, this thing inside, I know it's 6. So I now go f of 6. F of 6 is 5. So the answer to 52A is 5. Okay, B, they switch it. G of f of 1. You say, well, isn't that the same thing? Well, I don't know. Let's try it. So first I do f of 1. So f of 1 is 3. Okay, so this inside is 3. And now I do g of 3. So g of 3 is 2. Sorry about the yellow. I don't know why it does that. Okay. So the answer to B is 2, which is not the same answer as A. So again, f of g and g of f don't have to be the same. C, f of 1. Okay, so I do the inside, f of 1. F of 1 is 3. So I now know the inside is 3, and I take that 3 and put it back into f. So f of 3 is 4. So the answer to C is 4. Okay, D, g of 1. So g of 1 is 6. Now take that 6, put it back into g. So I want g of 6. So g of 6 way over here is 3. So it looks like the answer is 3. Okay. If you hear a funny whirring noise, that's coming from my computer. I'm getting a replacement computer on Friday. I just hope it'll last until Friday. So sorry about that. Okay, E says G circle F of 3. Okay, so you do F of 3 first. Okay, so G circle F means the same thing as this. But instead of doing 1, you're doing 3. So first I do F of 3. So F of 3 is 4. So that's 4. And now I take that 4 and apply it to G. So I want G of 4, that comes out to be 1. So the answer to part E is 1. And finally, F circle G of 6. So F circle G means the same thing as this. f parentheses g, except this time they want 6 instead of 1. So you do g of 6 first. Okay, so g of 6 is 3. Now I take that 3 and apply it to f. So f of 3 is 4. So it looks like the answer is going to be 4. Okay. All right. Now, 53, it's the same as 52. Only difference is that instead of a table, they give you a whole graph. All right? So you just have to look at the graph this time. And they got F in red, and the blue one is G. So use the given graph to evaluate each expression or explain why it is undefined. Some of these answers are actually going to be undefined. Okay, so why is it undefined? We'll see. Okay, so for instance, in this picture, suppose it says f of -1, right? There is no f of -1. The graph goes from 0 to, whatever, but there's nothing over here. So that might be undefined. And likewise for the G graph, it looks like it stops at what? 1, 2, 3, 4. So if we ask for G of 5, it's not defined, right? There is no blue graph at x equals 5. Okay, so let's try it. 53a, f of G of 2. So I do G of 2 first. So G of 2, that is the blue graph. So when x is 2, y is, I can't even see it, 1, 2, 3, 4, 5. Okay, so G of 2 is 1, 2, 3, 4, 5. Okay, so the inside is 5. And now I want f of 5. So f, red graph of 5, 1, 2, 3, 4, 5 is going to be here. So where's here? 1, 2, 3, 4. It looks like it's 4. So the answer is 4. Again, so these problems, there isn't any work. There's no work really. You just look at the graph and give me the answer. Okay, B, G of f of 0. So first I do f of 0. So red graph, 0. Oh, 0. So f of 0 is 0. And now I do the second function, G of 0. So G of 0 is up here. So where's here? Looks like it's 3. So the answer to part B is 3. Okay, C says F circle G of 0. It means you do G of 0 first, and then take that answer and apply it to F. Okay, so G of 0, we just did that. It's 3. Okay, so that's 3. Now I apply it to F. So I want f of 3. So f of 3, red graph, 1, 2, 3. Oh, it looks like it lands at 0. So the answer to C is 0. Okay. D, G circle f of 6. So that means first I do f. So f is the red graph, f of 6. 1, 2, 3, 4, 5, 6. It's going to be way up here. So where's here? 1, 2, 3, 4, 5, 6. Oh, okay. So f of 6 is 6. So that's 6. Now I take that 6 and apply it to G. So G of 6. X is 6. What's the y for the G function? Well, G doesn't go that far. Right, so D is undefined. Okay, I'm supposed to find G of 6. The blue graph, X is 6, but it doesn't go out that far. So the answer to D is undefined. By the way, don't worry about explaining. I mean, if you had to explain, you can just say, well, there's no graph there, right? But you don't have to. Don't worry about explain why there's no graph there. Okay, E, G of -2. So your G of G, pretend that F graph isn't there. Ignore the red, okay? Only look at this, that's all we're doing, right? So first I do G of -2. So G of -1, 2 is -1. Okay, so now I do G of -1. Same graph, go to -1, and I'm up here. Well, that kind of looks like 1.5. So I'll say the answer is 1.5. Okay, finally, F of f of 4. Okay, so red graph, there's no g. So this time completely ignore the blue graph. Ignore the g graph. We're only doing f. So f of 4. Whoops. Okay, 1, 2, 3, 4. 1, 2. So f of 4 is 2. Okay, so now I got 2. Apply that again to f. So f of 2 is down here. So where's here? It looks like it's negative 2. So the answer is negative 2 for that one. Okay. All right, and that is it. And that's as much as I was going to do. Okay, so I'm actually done with 1.3. I was supposed to have 1.3 tomorrow, so it looks like I'm a day ahead. So I'll just keep going. We've got extra time. We'll go for that. Okay, so let me stop sharing and turn off the recording.